Okay, so now we want to talk about what are some sediments that cover the ocean floor. But before we talk about that, I do want to remind you that underneath these sediments are the actual lithospheric plates. And so, what is an oceanic lithospheric plate composed of? So, it's going to have at the surface pillow basalts, and then underneath that is going to be more basalt, and then underneath that is going to be gabbro. So this represents the igneous rock gabbro, and then up here this is going to be basalt, and then up here is going to be pillow basalt at the very top. So that what happens is as material from the asthenosphere is coming up, it is going to harden at depth to make gabbro, and then in this region it's going to harden to make basalt. And then what happens though is when this stuff hardens, new material breaks through it, and it's going to make sheeted dikes that goes through this basalt. And then the dikes themselves are also going to be made of basalt. And then when this basalt makes it to the surface, that's what's going to be making these pillow basalts. So this is the solid part of the oceanic lithosphere. So on top of this are going to be sediments. So material that is constantly raining down, and it's going to be covering that rock. So what are some things that can cover it? Well, one is going to be biochemical. So this is going to be made by organisms. So organisms are going to be pulling certain materials out of the ocean water and then using it to make their shells. So one material that can be pulled out of the water is going to be calcite, calcium carbonate. So we said that carbon dioxide mixes with ocean water, and eventually that makes calcite, and that calcite can rain down onto the bottom of the ocean floor, and it can harden and turn into limestone. Another thing though that can happen is the calcium carbonate can be taken in by organisms and used to make their shells. And so here is a picture of it. So these are called foraminiferas. They are less than 1 millimeter in diameter. So if what I really need to do with this picture here is I need to shrink it down until those things are less than 1 millimeter. And then that would give you an idea for just how small those things are. And so they're the ones that are going to take calcium carbonate out of the ocean water and use it to make their shells. And then when they die, they can accumulate on the bottom of the ocean floor, and when they get cemented together, they could be limestone, and they could also be chalk. Okay, so let's go back to our original picture here. Now, one thing though about these particular kinds of organisms is if the pressure in the ocean water gets great enough, it's going to redissolve the calcite. So that's the reason why you'll notice that in the description here for these calcite ones, not deep, so that you don't tend to find calcite accumulating in the deepest parts of the ocean, because the pressure is just so great it will not allow the calcite to form. Okay, another type of sediment that you're going to find on the bottom of the ocean floor is going to be silica, quartz. And we found out in an earlier lesson that this makes chert. So there's two different ways of making chert. One method is to have ocean water that contains a lot of silica, and then it comes in contact with fresh water. And then that causes a chemical reaction that causes the silica to drop out. Now, what we're concerned with, though, is silica as a result of organisms. So in the same way organisms can take calcite out of the water and make their shells, other kinds of organisms can take quartz, silica, out of the ocean and use it to make their shells. And so that is what diatoms and radiolaria are. And so these are what those kinds of organisms look like, but look at their diameter, 0.1 millimeters. So these things are going to be 1/10 the size of these things over here. So again, in order to make it proportional, I would need to take this picture and make it roughly this big. So you can see that these foraminiferas are much bigger than what these diatoms and radiolaria are. But that's what they look like. And you'll notice that they occur in two different places at 0 degrees latitude, so that's going to be the equator, and then at 60 degrees latitude. And so if we go to this picture here, this is again a map of the ocean floor, and you'll notice this green thing right here. So that is one kind of organism that uses silica. And then you see this light green over here, and that is another kind of organism that is going to use the silica. And so it states down here where all of these different kinds of sediments are coming from. Okay, another thing, clay. So the materials that are coming from the continents are a mixture of sand, silt, clay, pebbles. So all of these things that come from rocks as they are weathered. The lighter the material, the further out to sea it can go. So quartz, for example, is pretty heavy. So quartz sand tends to accumulate near the shoreline. But far out to sea, you could have your clay particles. So that the very deepest parts of the ocean floor are going to be covered in clay. You'll notice this like with the Titanic, that there's this kind of like this ooze that is covering up the ship, and so some of that is calcite, and then also some of it is clay particles. Okay, then you've got precipitates. So precipitates occur wherever the ocean is evaporating, and so you could have calcite in place can be precipitated where ocean waters are evaporating. Also, you could have gypsum. Then there are these, another kind of precipitate are called iron manganese nodules, and they are about the size of a golf ball, and you can find these on the bottom. Some of them are made of pure iron, others are made of almost pure manganese. And so it has been thought that maybe if we had a gigantic net, we could drag it along the ocean floor and we could harvest these nodules. Well, the problem though is that it would be causing a lot of ecological damage, because a lot of other things would get caught up in those nets. But those nodules are on the bottom of the ocean floor. Okay, then you also have detrital materials, and so these are rocks and other sediments that are coming off the continents, so they're going to be located next to the continents. You're going to have volcanic debris, so that was things like ash when it falls out of the sky, and then other volcanic rocks, so that's going to be located next to volcanoes. You could also have material that is being pushed out to sea by a glacier. So later we're going to talk about continental glaciers and fjords, and how these glaciers will push materials in front of them, and then those materials, once the glacier begins to pull back, they just fall wherever they're at. And so next to glaciers you can have glacial materials, and then you have cosmogeneous type materials, and these come from outer space, things like meteorites and micro debris that can cover the floor of the ocean. So once again, you might want to take a look at this picture, and you notice this blue area here. Okay, and if you compare that to back to this picture here, so you notice that that corresponds to this green area right here. So this is relatively shallow compared to this area here, which is very, very deep. So if we go back to this picture again, so again, notice this is less deep ocean floor, and then this is the deeper ocean floor. And so you'll notice that there are different kinds of materials that accumulate in different parts of the ocean floor. All right, let's take a break. When we come back, we're going to talk about what are the tides.